In today's lesson, we are continuing to talk about special segments in triangles. And today's lesson kind of doesn't look like it's dealing with triangles, but I assure you we're leading into that. We're talking kind of in vague terms about two different kinds of bisectors. We're talking about angle bisectors and perpendicular bisectors. We have defined those terms before. What we're looking at that's kind of interesting to us is new properties of perpendicular bisectors and angle bisectors. Before we get into that, however, let's talk about what it means to be equidistant. If a point is equidistant from two objects, let's call those two objects, let's just call them objects, just to be vague. If a point is equidistant from two objects, what do you think that means? Think about that word, equidistant. Jesse? Exactly. A point is equidistant from two objects if it is equally far from both. If I'm talking about, if the objects, rather, that I'm talking about, let's put the phones away, please. If the objects that I'm talking about are 2 points, let's say this is point A and this is point B, point is equidistant from those 2 points. Let's say this point X would be equidistant from points A and B if this segment is congruent to this segment. Make sense? X is equidistant from the points A and B. Well, let's take a look at segment AB. What point on AB would be equidistant from points A and B? I'm looking for a vocabulary term. What point on segment AB would be equidistant from points A and B, Zoe? The midpoint, absolutely. So let's call that point Y. And as Zoe said, that's the midpoint. And now finally, if I draw the line connecting point X and point Y, do you visually see that that line XY, is not just the bisector of that segment, since it's passing through the midpoint as Zoe described, it's the perpendicular bisector of that segment, which kind of leads us into what we will call the perpendicular bisector biconditional. In your book, I'll give you fair warning so that when you see it in your book, you're not alarmed. In your book, it has this property broken up into two separate properties that are converses of each other. Since we're not doing proofs with this property, I'm not concerned with you identifying which one is the theorem and which one is the converse. What's important to me is that you know it's true and you know how to use it, right? So, a point is on the perpendicular bisector of a segment if and only if, what do you think? Where did I just come from? If it's equidistant from the endpoints. Let me scroll this up a little bit. So a point is on the perpendicular bisector of a segment if and only if it lies. Oh gosh, sorry, I'm about to say it lies on the perpendicular bisector. Point is on the perpendicular bisector of a segment if and only if it is, as Helena said, equidistant from the endpoints. And I feel, I'm pretty confident I should say, that a lot of you are going to like what these diagrams and problems look like a whole lot more than last lesson. Because in yesterday's lesson, you had to know which segment to double or which segment to take half of before you set it equal to the other one. Think about what this property is saying. These things are equally distant. You're going to be doing a whole lot of just setting things equal to each other. It's very intuitive. The equations look like you would expect them to look. We have from this screen what we need. Okay. So, in problem 1, as I said, you're setting up an equation in order to solve for x, and it's going to look exactly like you think it's going to look. How do you think it's going to look? One person, please. What equation do you think I'm going to set up here, Michael?
It's x minus 1 equals 3x plus 8.
Exactly. And then solving for x, we subtract the 3x. Add the 1. And x equals 3. Woohoo! Solve for x. Move on? No. Did I go back and look at the question yet? No. Let's go back and look at the question. What is the question? Is it just what's the value of x? No. It's find the length of mn. How do I do that? We plug it back in, yes. So 6 times 3 is 18. 18 minus 1 is 17. Now we have answered the question. Now we are done. Please take a moment within your groups and look at the your turn for problem 1. Okay, we're looking pretty solid, so make sure that you have in your notes what I am presenting on the screen. 2 expressions set equal to each other. Solving for n, we find that n is 3. And plugging back in for the length of QR, we have that its length is 8. Did I do something wrong?
I got yeah, Ellis and I did the same thing. I got 8.
Okay. Oh, there we go. You dropped a negative sign. -7 plus 1. Okay, in problem 2, kind of a real-world application, we're asked which attraction at the playground is equidistant from the slide and the tether ball. What's equidistant from the tether ball and the slide? The 4 square and the monkey bars, because they both, do you see, would lie on the perpendicular bisector of the segment connecting them. And really, the monkey bars is kind of a given because it tells you that in the instructions, that it's located midway between the slide and the tether ball. So we're not going to restate the obvious. Our answer is the 4 square. Okay, so that's basically the bottom line as far as the perpendicular bisector theorem and its converse. That any point on the perpendicular bisector will be equidistant from the endpoints of that segment. But what gets a little hairy is when we're talking about the distance from a point to a line. Let's make sure that we're all talking the same language then. Consider that point and that line. If I asked someone to take this ruler and measure the distance from that point to that line, I would be curious how you would place that ruler. Measure the distance from the point to the line. How would you place the ruler in order to measure that segment? Jesse? Those are terms I don't understand. Show me. I know you love coming up to my board. Okay, now she said straight up and down, which, oh, no, you leave it the way it is. I like that. Okay, so the straight up and down qualify as
Vertical.
a response. Say it again.
Vertical.
Well, it was vertical before, but if I draw a vertical line from that point to that line, is that the distance from the point to the line, or is there a different vocabulary word that you would like to give me? No?
I don't know.
Where would you put the ruler? Where would you put the ruler? You're trying to measure the distance from the point to the line. No? Someone want to help her out? Thank you. Lily, show me. It's a line. So a line is infinite and it doesn't have a midpoint. I want the distance from a point to a line. Where would I put my ruler so I can measure that distance? No? Michael? Ooh, I love the vocabulary. Yes, absolutely. You would make a perpendicular line from the point to the line and measure the length of that segment. Yes. So, when we're talking about the distance from a point to a line, what we are measuring is the length of the perpendicular segment from the point to the line. So the next property, as you can see, is dealing with an angle bisector. So let's take a look at an angle bisector. I have an angle. And it's been bisected, and it has many, many points. On that angle bisector, let's just choose a random one. Let's call this point X. Well, Mrs. Clouse, why did you just talk about the distance from a point to a line, and now you've shifted to talking about an angle bisector? Here's why. Because this point X is, in fact, equidistant from the sides of the angle. And once again, when you're looking at these problems, look at the way that property is phrased. Equidistant. Things are equal to each other. These equations are going to set up exactly the way you would think they would. Hey, good question.
Is there like a way that you can write equidistant without like actually writing it?
There is no symbol for equidistant. Okay, so a point in the interior of an angle is equidistant from the sides of the angle if and only if it lies on the bisector of the angle. Let's go over what was here when it cools down outside. We're still getting from the screen what we need. So in problem 3, I don't know why my quality on the screen is so bad. Hopefully it's a little clearer in your notes, not by much. How would we set up this equation? In problem 3, notice that I have an angle bisector. Sarah?
6x equals 3x plus 12.
Absolutely. So 3x equals 12 and x equals 4, and I have successfully solved for x, so I must be done, right? No, always go back and look at the question. The question is asking me for the length of OP, so I need to take that 4 and plug it back in. OP equals 3 times 4 plus 12, so that's 24. And once again, please take a moment and look at the your turn for problem 3 before I activate today's daily quiz. Since the instructions were only asking for the value of x, you would stop at x equals 3 for that do now.